Assalamualaikum and hi, welcome to our group presentation. Our topic is Building Construction of Industrial Building System, or known as IBS. Here is my group members, Husnaa, IMANINA, KAMIL AFIFI, NADHIRAH, AFRINA ATIKA, and lastly me, ALIA.
Hi, my name is Husnaa. Here I will start with introduction of IBS. In Malaysia, construction industry have developed an innovative development method called Industrialized Building System, or we call it as IBS. So in this method, we will produce a prefabricated material with mechanized process and standardization for off-site and on-site assembly by not using such a heavy labor. This method will produce precast panel steel frame and modular unit in control factories to guarantee their strength and durability, and by that, it can cut the construction period by 15% to 70%, and it will minimizing a risk. By using this method, issues such as a shortage labor, rising costs, and sustainable demands can make sure that IBS can deliver more faster essential of construction, such as hospitals and rural clinics, aligning with the global trend while boosting the national development. Next, I will tell you about the type of IBS and the component they produce. First is the precast concrete system. In this type, they commonly will produce a column, beam, hollow core slabs, staircases that molded in reusable factory forms with poured concrete and reinforcement. The concrete will be cured under controlled conditions with optimal strength and ensuring high quality. Once the component meet the requirement, the components will be shipped to the construction site for a quick connection and cut the period of time while maintaining their durability. Here are the picture is the example of the precast concrete in the construction site. Next type is steel framing system. In this type, they will produce components such as prefabricated galvanized from steel, as example, C-sections, beams, columns, and trusses. The characteristic for this type is they will shape the steel in the room temperature for superior durability, strength, and precision factory production. This type is lightweight, reduce the foundation needs, and it has excellent strength to weight ratio. This type will be designed by the engineer first, and the design will be sent to the factory for its production. Here I attach the photo of example usage steel framing and construction industry. Third type that I will introduce is the timber framing system. It is the same function, and that is for the framing with the previous type, but this type use a timber for their material. The components for this type usually pre-assembled wall panels, roof trusses, floor joists, stud with insulation, sheathing, and bracing. The factory process for this type, they will build in the control factory setting for sturdiness, strength, and sustainability. They will effectively transfer vertical or horizontal load such as wind to the foundation. Next type is the block work system. This type uses a larger precast concrete or cement block for faster wall construction. There are three types of blocks in this type. Firstly is the interlocking blocks. It is a tri-stack block with studs or recesses. They no need a mortar for the jointing. Next type is the hollow core blocks. These blocks lighter and have about 25 to 50% void. Last type is the AAC blocks, and it is the lightweight block that contains cement, lime, sand, fly ash, water, and aluminium powder. It will be cured under high pressure steam. All these types will be used based on the functioning for each building. Last type for this topic is the plastic combo. This type is the temporary mold that will shape the concrete until it hardens. For IBS, they will be using a reusable material for efficiency. There are two types of formwork, and firstly is the timber, where they will reuse a plywood with props or roller, and this type is cost-effective but less reusable. Next type is IBS formwork, where they will use a reusable steel, aluminium, plastic or modular panels for slabs, beams, columns, and wall. This will cut costs on formwork and can be used for multiple projects to ensure smooth finishes and shorten timelines of the projects.
Moving on, let's talk about our case study, which is proposed 1-unit bungalow 1.5 story at Bandar Tasik Puteri, Mukim Rawang. This project is a 1.5-story bungalow with a total built-up area of approximately 3,000 square feet, located in Rawang, Selangor. The house is designed using IBS wall panels to improve construction and reduce overall structure load. The project started in October 2025 and has a planned duration of 8 months, with an estimated total construction cost of RM580,000. The use of IBS contributes to faster construction and better cost control. The bungalow consists of master bedroom with attached bathroom, guest bedroom with bathroom, living and dining area, kitchen, laundry area, veranda, and car porch. Moreover, the house uses a concrete tile pitch roof with a 25-degree roof pitch. This roof type was selected for its durability, good thermal performance, and suitability for Malaysia's tropical climate. For the IBS, we use IBS wall panels. We are using stucco AAC vertical wall panels, which are CIDB compliant and achieve an IBS score of 1.0. The panels are locally manufactured, which reduces material lead time and transportation costs. Also, the project adopts a hybrid construction system. IBS AAC panels are used for a wall construction, and conventional reinforced concrete is used for beams, columns, floors, and roof structure. This approach ensures structural integrity while maximizing IBS benefits. So, the combination of IBS AAC wall panels and conventional RC structure provides an efficient, economical, and sustainable solution for a residential bungalow, and it shortens construction times, reduces structural load, and complies fully with CIDB IBS requirements, making it highly suitable for this project.
Thank you to ADLIN, and my name is NADHIRAH, and I will present to you about the parties involved. And before we start, I will explain to you about what's the meaning and what's the definition about the parties involved. So, for the parties involved in construction project, each party has specific roles and responsibility, and their decision directly affect the project. And for the first one is client, which is our main parties, which is they are define the project requirements, budget, and timeline. Also, they are approve the design. And for the next one is the contractor. Their roles is execute construction work according to drawings and specification. They are manage labor, machineries, and material. They are coordinate with the supplier and subcontractor. Also, the next one is architect. They are prepare architect drawing, and they are depends from the requirement of the client. If the client want to change the design, they have to make the reverse drawing. And for the next one is engineering. They are design the engineer and structure system drawing, and they are with the specific of the client. They are required with the specific of the client, and they makes structure design, new calculation, and replacement of the prefabricated components. And so And for our clients, we have Muhammad Afandi bin Othman and Siti Nur Sabrina binti Tajadin. And for our contractor, we have MFD Builder Resources. They are specialists for MBS building, and they know how to find and how to construct the IBS building. And for the architect and engineering, we have Hazri Hassan Architect and LCS Engineering Service.
For process and material used in project, the process begins with the client providing the concept and design requirement. The designer then creates a 3D model showing the layout and functionality of the building. This design must be approved by the client and relevant authorities before construction can start. Then, IBS panels are produced in factory with a double steel reinforcement for strength. Panels are made in a standard size of 12 feet by 2 feet to simplify handling, transportation, and on-site installation. After production, the panels are transported to the site using lorries. On-site, a crane lifts the panel to the installation area, ensuring safe and efficient handling. Before panel installation, all main structural work, such as foundation, column, and beam, must be completed. The site is then prepared and panel positions are marked to ensure accurate placement and safe work conditions. Panels are lifted and positioned using a crane. They are measured, cut if needed, and aligned accurately. Joints are secured with specialized cement and temporary bracing, followed by plastering for smooth internal and external finishes. Then, after installation, the panel undergoes inspection and testing, including load and vibration tests. Any defect or misalignment are corrected to ensure the structural safety and quality of the building before handover.
Material used in the IBS is specialized cement, crane and lifting, and L bracket.
Assalamualaikum and good day to everyone. My name is AFIFI, and in this section I will present a comparison between the Rawang Bungalow project titled Cadangan Membina, 1 unit bungalow 1.5 tingkat di atas lot PT 33911, and the CIDB IBS demonstration bungalow. The purpose of this comparison is to better understand the effectiveness of the industrialized building system, or we call it as IBS, as applied in a real residential project and a demonstration project. Both projects are residential development that adopted IBS principles such as prefabrication, standardized component, and fast-track construction in line with CIDB IBS guidelines. Firstly, in terms of similarities, both projects share the same construction philosophy. Both apply off-site manufacturing as a core IBS principle. In the Rawang Bungalow, wall panels, specifically stucco AAC vertical panels, were manufactured in factories and assembled on-site. This helped to reduce dead load and improve construction efficiency. Similarly, the CIDB IBS demonstration bungalow adopted a full IBS system where major structural elements such as walls, slabs, beam, staircases, and the roof trusses were precast in factories and then assembled on-site. This resulted in better quality control, reduced site waste, and less reliance on wet trades. Another similarity is in delivery and installation planning. For the Rawang Bungalow, the IBS wall panels were transported by lorries and lifted using cranes directly to their installation position. This ensured safe handling and minimized damage. Likewise, the CIDB IBS demonstration bungalow used a just-in-time logistic system where components were delivered according to installation sequence. This helped to avoid site congestion and improve productivity. So, next one, we move to differences of this building. There are also differences in the installation of jointing process. In the Rawang Bungalow, installation involved manual alignment, temporary bracing, L brackets and wall plugs, and the use of specialized cement grout for wall-to-wall and floor-to-wall joints. Panels were tapped using mallet to ensure proper contact, followed by external plaster rendering and internal skin coat for finishing. On the other hand, the CIDB IBS demonstration bungalow used modular precast connection which reduce the need for on-site cutting and manual adjustment, resulting in more uniform finishes. Another difference relates to project function and design flexibility. The Rawang Bungalow is a private residential project, right? Tailored to the client's specific preference and requirement. This required the integration of IBS with conventional method to meet the design requirement. Meanwhile, the CIDB IBS demonstration bungalow was built as a model project, focused on standardization and efficiency with less emphasis on architectural flexibility. Last but not least, we move to the challenges. In terms of challenges, the Rawang Bungalow faced difficulties in integrating IBS component with conventional construction methods. In contrast, for the CIDB IBS demonstration bungalow, faced challenges related to logistic and coordination of multiple IBS components. And despite all of these challenges, both projects demonstrate that IBS significantly improved construction speed, safety, and quality when properly planned and managed. So, we come out to our conclusion. This comparison shows that IBS is flexible and adaptable to different types of residential project. For custom, single unit project like the Rawang Bungalow, a hybrid IBS system is more suitable. Whereas, for demonstration of standardized projects such as the CIDB IBS demonstration bungalow, a full IBS system is highly effective too. So that's all from me. Thanks.
And next, I'm going to present about problems that occur. And I'm going to break it down to 3 points. So, for the first point is labor difficulties in transporting heavy equipments and materials. First, one of the main challenges in IBS construction is the difficulty in transporting heavy equipments and materials. Prefabricated components such as wall panels, slabs, and beams are large and heavy, which makes manual handling difficult and inefficient. This leads to safety and health risks for workers. Improper lifting techniques can cause fatigue, injuries, and on-site accidents. This may affect the productivity and project progress. Therefore, proper support is needed on-site. The use of crane, forklifts, and other lifting equipment, along with proper training and well-planned work schedules. This can help reduce the risk and improve overall productivity. Next, the second point is high machine costs. High machine costs are another major challenge in IBS construction. Specialized machinery is required, and these machines are expensive to purchase, rent, operate, and also maintain. These high costs are expensive to purchase. This equipment breakdowns or poor planning may lead to delays, additional expenses, and inefficiencies during construction. To control these costs, effective strategies must be implemented. Proper scheduling, regular maintenance, and equipment sharing, or perhaps a rental option, can help reduce unnecessary expenses, and this also ensures smooth project progress. And lastly, the third point is defect costs, which is 5%. Defect costs are also a concern in IBS construction, even at a relatively low rate of 5%. Defects might occur during prefabrication, transportation, installation, or finishing works. Although these defects may seem minor, they can increase both cost and time. Rework requires additional labor and materials, which can delay project completion. To minimize defect costs, strong quality control measures are essential. So, regular inspections, close supervision, good coordination between teams, and proper staff training helps to ensure the quality construction and also reduce the likelihood of defects. And next, I'm going to talk about the solutions. And I also will break it down into 3 points. For the first point is use of lifting equipment and proper handling methods. First, the use of proper lifting equipment is essential in IBS construction. Equipment such as cranes, forklifts, hoists, or trolleys helps workers handle heavy prefabricated components like wall panels, slabs, and beams safely and efficiently. So this reduces the physical strain on workers and also improves overall productivity on site. In addition,
Worker safety and efficiency can be improved through proper handling methods by using suitable equipment which minimizes fatigue, reduces the risk of injuries, and prevent work disruptions caused by manual handling. Lastly, training and proper work management are important. Workers should be trained in safe handling techniques and correct use of lifting equipment. Task rotation and scheduled breaks also helps maintain productivity and reduce exhaustion. Next, the second point is efficient management of machinery costs. Machinery cost is a major challenge in IBS construction due to the need for specialized equipment. So these machines are expensive to purchase, rent, operate, and also maintain, which can be significantly affect the project budget. To manage this equipment, usage must be optimized, like proper scheduling ensures machines that are used only when needed, while renting and sharing equipment, which can help reduce the unnecessary expenses. Finally, regular maintenance and monitoring are also crucial. Routine servicing helps prevent the breakdowns, avoids delays, and reduces unexpected repair costs, which ensure smooth construction progress. Last but not least, the third point would be strict quality control. Strict quality control must be implemented throughout the project. Quality checks should be carried out during prefabrication, transportation, and on-site installation to ensure the components which meet design and quality standards. Early detection of defects is also important. Regular inspections and supervision help identify issues at an early stage, which reducing rework, delays, and also additional costs. In conclusion, strong coordination and also proper documentation supports effective of quality control. Clear communication between teams, inspection records, and also compliance with construction standards helped ensure high quality IBS construction. Thank you.